right, so when we're working with imaginary numbers, so like you're like, whoa, imaginary numbers. So we have real numbers, which you've been working with your whole life. Like that's just going to be your positive and negative numbers. And that's your like, starting at the very bottom without getting too deep into this is like, if you think about a Venn diagram, sorry about that. If you think about a Venn diagram, inside the Venn diagram, you are the real numbers. And in the real numbers, you started off and you had your counting numbers. And then you had your whole numbers. And then you had your integers. And then you had your rational numbers. I'm just going to write rat numbers. And those are kind of like their own circle. And then this other little space inside of the world of real numbers are called irrational numbers. And that's still not what we really have. We have imaginary numbers, but like these are like the numbers we've been working with. So like this, the famous famous irrational is pi. Counting numbers start at 1, go 1, 2, 3, all the way to infinity. Whole numbers are, because this is a Venn diagram, whole numbers just add on 0 to the previous list. Integers add on negatives. So like we got negative infinity, oops, and then dot, 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 -3, -2, -1, and then 0, and then 1, 2, 3. And then rational numbers add in like fractions, like 1/2, terminating decimals, repeating decimals, so like 1/3, which is equal to 0.3 repeating, and so forth and so on. So irrational numbers are like pi, like a number that doesn't terminate, it doesn't have a pattern, it just goes on forever. Square root of 3 is another irrational number, as an example of an irrational number. So these are all the real numbers, what we've been doing. Now we have this new number system out here, and they're called the imaginary. And there's multiple. This isn't the only other number system, but there's like this other number system in our world that we work with. And so imaginary numbers have some unique rules. Like for example, one unique rule is that if you get I squared, that's equal to -1. And so in this case here, we're going to use that. And so we start this problem off, and what our deal is that, oh, and by the way, imaginary numbers are always written in the form of a plus bi, where the a value is the real number portion. So that's like the real number part. And then this part is the imaginary number part. All right, and so we kind of put those two together. So we have this situation, we have 3i over 6 minus 5i. And we want to put this into the format a plus bi. So we got some stuff to combine here. Well, one way we do this is what we kind of rationalize the denominator. We kind of try to get rid of what's in the denominator, to get rid of the imaginary numbers out of it. And so in that case there, the one way of doing this is to multiply, let me see the eraser. There we go. So one way to do this is to multiply by, and my brain is not remembering what this is called right now, so we're going to just go with it. And so we multiply by, you can see it's just the opposite of the 6 minus 5i, so the 6 plus 5i. And so when we do that, what happens when we FOIL these two together? So when we take this guy and we FOIL it. So in the denominator, we take 6 times 6, that gives us 36. I'm going to change colors so it stands out. We take 6 times 5i, that gives us plus 30i. And then we take negative 5i times 6, and that gives us negative 30i. And then we take the negative 5i times the positive 5i, that gives us negative 25i squared. So the reason I made the orange here the same color, you'll notice those are exactly the same terms. So by doing this process, what happens is these terms cancel. So now we've gotten rid of those i's. And you might say to yourself, well, wait, Fix, we still have an I right here, but no, you don't. You have I squared. So in imaginary numbers, when we have an I squared, we let I squared be equal to -1. So this becomes 30, oops. I gotta give myself a little more room. This becomes 36 minus 25 times -1, because the I squared becomes -1. Well, two negatives make a positive. So this becomes 36 plus 25. All right, so at this point right now, our denominator is going to be 36 plus 25, which is 61. So we're going to put that over here, kind of working in a square here. That's kind of weird, but whatever. All right, so now let's take care of the numerator. So as a consequence of doing this stuff to the denominator, we had to do the same thing to the numerator, because essentially all we've multiplied by right here is by the quantity of 1, because it's the same thing on top, same thing on the bottom, that equals 1, right? So for example, if we had 4 over 4, that's equal to 1. 4 divided by 4 is 1. So this expression divided by that expression is equal to 1. So I really haven't changed the value of my expression here. I'm just changing the way it looks. So same thing, I'm going to multiply 3i, distributed property, times 6. That gives me 18i. I'm going to take 3i times 5i. So that's going to give me 15i squared. Okay, once again, I have an I squared right there. So we bring down the 18i. The I squared turns into negative 1, and so this turns into negative 15. So remember, I squared becomes negative 1. A negative times a positive gives me a negative. All right, so now I'm essentially done. So now this numerator can't go any further. It stays just like it is. And so I come over here and I have 18i minus, 15. Yeah, minus 15. All right, but that's not in the format a plus bi. So if you did plug that in, my lab will tell you that's actually the correct answer, but we need to simplify it into the imaginary number format. So that means I'm going to take this, and let's go to a color I haven't used yet. Let's go pink. So that means I'm going to take this and I'm going to put 18i over, darn it, sorry, there's a little button on my pen, and I touch that button as I'm writing, and it kind of keeps it going. And that's kind of a mistake on my part. So 18i over 61 minus 15 over 61. So I'm going to pull out my rusty trusty calculator. I'm going to see if any of that simplifies. So I'm going to take 18 over 61. Now I'm not going to plug the I into my calculator because my calculator is not going to know what I is. So 18 over 61 doesn't simplify. So now I'm going to try 15 over 61. It doesn't simplify. So now this is my final solution. I know you're like, well, that's not the same thing here. But remember, A is a real number. So A can be written as a fraction. B is a real number. So B can be written as a fraction. And so I is the part that makes it imaginary. So my answer that I'm going to submit is going to be this guy in purple right here. So I come up here. Oops. Let's doop, doop, doop. Mouse. All right, and then you'll see when I hit that, there's a fraction bar that pops up down here, so I can click the fraction bar, and I do 18i over 61. I arrow out of it, so I'm up next to it. I hit minus. You also can just type the first number, hit the fraction bar on your keyboard, and it'll change it into a fraction, and then do 61. So you can see throughout that writing there, you can see I got the answer plugged in. I click check, and I got it. All right, so lots of little edumacation going on here inside this question, but this is section 1.4.